All right, lab participants, here's a recap of what we did in lab. So reminder, on the course blog, I have a section called labs, and I will post each lab here. So right now we just have the data collection lab. And I've added a little bit since yesterday. So just a warm up to the actual lab, we have some data from BMCC enrollment, and I've moved that into a Google spreadsheet. So I downloaded from the college database a bunch of data about classes this year. I scrubbed it a little bit, and it may be that I over-scrubbed, maybe that I under-scrubbed. If you want to talk about scrubbing some more, come see me. So I have a variety of columns left here. We have a unique course ID number, we have a course title, I kept the days of the week, the location of the class in terms of room and place, the campus, the department that offers the class, the enrollment, enrolled combo, seats available, and there were 50 or so columns. I ditched a bunch of them. Here I have a summary I'll talk about in a minute of some of the data. So you can scroll down and explore the data. There are 283 entries left after I scrubbed it, I think. I don't know how many there were originally, but I have the original data set if you want that. Enrolled versus enrolled combo, what the hell does that mean? Well, enrolled combo means that multiple courses or sections here, rows, added up to give a combo result. So what you find mostly, if you sorted these by title, that there would be a few courses together for which this 12 comes from. Usually it's easy to see if you order these right, which courses combine to give the combo, but it is not always easy to see. I believe the 0 in the combo means that there wasn't another section combined with this one to give the total. So here, there were 15 students in this section. There's another 9 somewhere that contribute to a total of 24 for this class. So instructors sometimes stack classes. Kind of a weird thing to think about, and we'd have to piece that together. It may mean getting further information from the source of the data, the database, an administrator, and try and figure out what to do with that data. So I included in there just to let you know that even though somebody has great intentions about how they collect data, it can often be hard to interpret the results when you're looking at them, and then you have to do further research, decide what to keep, what to get rid of, and how to scrub things. So that's always a challenge. So now this is a small data set. There's only 283 entries, so I could easily analyze these numbers directly, and I'll do that in a minute. What I want to talk about next is sampling. We talked about a couple of different kinds of samples. So let's go over here and focus on just one of these columns to the right, one of these sections. So here I have a simple random sample. And a simple random sample means each group of a certain size has the same chance of being selected as any other group of that same size. So I selected randomly 32 rows from the data set. So down here, we'll see, eventually, here's my 30-second entry. There we go. So my 30-second entry is row number 188, and there were 9 students in that section. So the reason I'm looking at this data is there was a claim that enrollment is down, which seems to be true based on classes I've had, although statistics enrollments are up. And that the average class size has shrunk as a result, because we have a similar amount of sections we had last year, but we have less students to put in those sections. So I just want to kind of explore that idea by looking at some data. So my simple random sample, I achieved these numbers 74, 126 by using the command rand between. So for example, to use that command, I type rand, it was offering me the option between. And then if I click the question mark, oops, where'd it go? There we go. If I click on it, it tells me more about it, how to use it. So it's a high value and a low value. So I have, let's see, 283 rows. Since there's a header, that means there's 282 entries. So I want from 1 through 82. So that will randomly grab me one of those. So there it says number 276. I can then use another function called index. And what index does, an index is a position in a list. So I can use this number 276 to find the 276th entry in my list of enrollments. So if I use the index command says, what are you trying to reference? And I say, I'm trying to reference this data over here, enrollment. And so I highlight all of my enrollment data. Now, this isn't something you need to remember about the Excel commands. I'm just showing you how one might use Excel to do certain things. Then it wants a comma, and then it wants to know what row I want in there. And I want to use my random number to grab that row. So I say, there's my random number. I can also give a column if it's multi-column data, but this isn't. And so I just close the parentheses and enter. And it switched my random number when it did that. So now I can see that in the 99th row, there are 5 people in that class. So that's how I made my selection. I did a bunch of random numbers, and then I used the index command to find the entry that went with that particular randomly selected row. So I get all this data right here. I repeated that by using a systematic random sample. So I have 2 different random samples here. A systematic random sample is where you pick a random starting place in the data, like here, and then we maybe jump every 4th number and pick that number. 1, 2, 3, 4, pick that number. So we could go and do that manually. I chose to do it by randomly generating a number between 1 and 20 as a starting place, randomly generating a number between 3 and 10 as my jump. So here I'm starting at entry 2, and I'm jumping by 8. I chose to combine those first and get this number 10, which is the result of 2 random numbers, and then I'm going to get every 8th number from there. So that would be 10, 18, 26, 34, 42. And then I told the computer to look in each of those rows and tell me what their enrollment was. So this is a systematic random sample. This is a simple random sample. Right? There's tons of different sampling techniques out there, most of which involve some kind of random generation. Okay, so scrolling down here, what do we know? Slow down. Here I then found the average. From the systematic random sample, I found that there was an average enrollment of 15. From the simple random sample, I found that there was an average of 9.4. I then decided to look at the histograms for each of those random samples. And so I made a frequency table. So I used the frequency command to do that. We've gone over that a couple of times now. You can see the numbers look slightly different. My bins are the same sizes. And then I built those histograms. Shrink this down a little bit so we can see 2 of these together. Okay, so here is the systematic enrollment sample. Now notice that it's heading way out to the right. Why the hell is it doing that? Well, if you look at the data to find the minimum and the maximum, you find that there was one course where there was 123 students in it. Most other courses didn't get higher than 35, and even 35 was kind of rare if you look at these 2 random samples. They have a kind of similar shape. They have most of the data is in here. So what this means is there in my sample, there were 7 classes that had from 0 to 5 people in it. There were about 7 classes that had from 6 to 10, and from 11 to 15, there were 8. This one's a little bit different. Here I can see there were 11 classes that had 0 to 5 people in it, and so on. So slightly different, kind of similar. This random sample grabbed that extra weird data item. So we then have to decide, well, that's an outlier. That's way different than anything else BMCC does. Do we count it or not? And that's a decision you have to make. Was it a mistake? Did they mean to just type 23 and 123 got in there accidentally? So there's all kinds of considerations to make. I repeated this situation, and so I did another systematic and another simple random sample. So here, same exact procedure, different starting point, different jump. Here it's just a different list of randomly selected numbers. So this group of 32 is just as likely to get selected as the other group of 32. Take a look at the frequency tables. Here in the frequency tables, there were no entries over 35, so that class of 123 didn't get selected in either of these random samples. You can scroll. Here we can see that the average enrollment was 11 for the systematic random sample and 10 for this. And I mentioned in the lab, I'm sure I mentioned this in class before, that you're always better off doing multiple small random samples than you are doing one big sample of the population. You'll always get better results by taking a few snapshots. And if we look at their histograms, systematic random sample above, and the simple random sample below here, we can see that they are a little bit different, but still kind of similar. There are a few classes out in the 30s. Most of the classes are bulked up in the small class sizes. The simple random sample shows that there were more classes between 5 and 15 students than there were in any other category. Now, since we had all the data, I decided to take a look at what the actual data set said. So here is a histogram, same style for the entire data set. And so it looks a lot like this simple random sample, similar shape. And it's got that outlier way out there of 123 way out to the right. Notice that there's nothing in between. So what do we do with that data? And that's a hard question to answer sometimes. And again, I say this is most of the enrollment data because I did scrub it. There were a whole bunch of classes that were in the listings with 0, and they weren't listed as canceled. I didn't know what that meant, so I took it out. My boss may decide that that's significant. I would have to go talk to him about that. There were also a bunch of classes with 1 student in it that I pulled out. Maybe that was a bad idea. Probably was. So I can get an average of this whole set by just coming down here and typing average, or I could go to the commander, look for a command that does average. Again, it tells me what it does. So I need to select all the data that I need. And that is the wrong column, isn't it? Yes, that is the available column. I want this column. And one will often make accidental selections. As long as you fix it, you're okay. So, come on. All right. According to my scrubbed data, we're getting there. There we go. Close parentheses, hit enter. The average is 10.2. Now, the rule in making calculations, statistics, this would be a parameter if that's the whole population. Is to take it to 1 decimal place more than the actual data. Since my data is whole numbers, then I should say the average number of students is 10.2. Now, that's kind of weird. Like, what is 0.2 of a student? That sounds kind of bloody. So we could say it's really 10 students on average per class according to the data that I have here. And again, looking at my samples, my second simple random sample had an average of 10. My second systematic sample had an average of 11. My first systematic sample had an average of 15. My first simple random sample had an average of 9. So again, if you can't get all the data, you want to take multiple small samples. And small depends on the size of the original population and a bunch of other things. And we'll get to how to choose a sample size later in the course. For now, we're just playing around. Okay, so you can play with this data more if you like. By the way, Google is very good at making histograms. To make a histogram here, I don't have to do that frequency table, which is kind of complicated to make. I can just highlight any particular numbers I want, like maybe the enrollment from the original data set. and then I just say, Google, make me a chart. And Google says, how would you like a histogram? So it automatically does frequency. Now here it's going a column width of 8. We'll talk about what column widths in the next class and how many columns you should have. And I can always customize it to say I want them done differently. So if I scroll down here, I can change the bucket size. And maybe I want a bucket size of 5 instead, and it'll automatically update it. So I can play around here very easily with different bucket sizes, trying to find one that I like. And I could just do, generally what you do is a bunch of different ones and hold them side by side and talk to a couple people about it and make a decision on which one or ones you think best illustrate whatever you're trying to show about the data, or whatever you discovered. And different histograms might show you different features of the data. So here, as far as I could say, the 5 to 10 students is the mode of the data, because that is the tallest stack. So more classes had 5 to 10 students than any other class, than any other number. All right, out of there. All right, let's get back to the lab. So blah, 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 blah. Okay, so here we go, lab. What you're gonna do is do the activity in the book. It's section 5 or 6 in the book. Here I have a link to the web book. It's on pages 41 and 42 in the real book. What we're going to do is we are going to ask a bunch of students or other people how many movies they've seen in the last month. In class, we decided that month wasn't descriptive enough. Does that mean March, or is it the last 30 days? So we just decided to use the last 30 days so that there's no question about that. We want to do it in a systematic way. So the description here in the lab in the book says to pick a classmate in some other class, and starting with a random person in that class, get every, say, 4th person until you've accumulated 12 names. Now, you could cyclically go through the roster to do that. So if there were, say, 10 people and you start with the 5th person and you're going to grab every 4, you would then grab the 9th person. And then counting up from that, you would go 10, 1, 2, 3. So then you've got the 3rd person next. So you just keep revolving through the list. One important point in doing that is if there were 10 people in the class, or let's say 20 people in the class, and you're the 5th person, that means you're going to cycle through the same people over and over again, because 5 goes into 20 evenly. You need a jump value that does not go into the number of people in the class. So if there's 20 people, you could do like 3 or 7. If there were 21 people, you wouldn't want to use 3 or 7. You would want to use something like 5 to jump around, so that you don't end up getting a repetitive list of people. So ultimately, we want to get 60 people. So some other suggestions that were made, so let's scroll down here. Instead of getting data from a college class, we could get data from a high school class. If you're a high school student and you have access to a class, it could be a workplace. Now we want to be careful about things like workplaces, because what if your workplace is Wild Horse Cinema? Might Wild Horse Cinema employees be more likely to see a movie recently than people that don't work at a cinema? I would think yes, but I don't know for sure. That could bias the data. You want to be careful about that. Another suggestion was to ask this question on Facebook. There's a couple of problems with that. One, is it possible that people that use Facebook often are more likely to see movies than people that don't use Facebook? I don't know if that's true, but it might be. It's a different audience than, say, a college class. So we're definitely getting different kinds of data. That could be good or bad, we're not sure. The other thing about Facebook is people are, on that one, whereas the systematic random sample in a college class, where we pick the people randomly, in Facebook they are self-selecting. So might somebody be biased to answer the question for some reason? Maybe because they like movies and they want to tell people, yeah, I've seen 5 movies. So we might get biased results from the Facebook sample. Now, let's do it anyway. So Kirsa in class volunteered to put that on the BMCC student Facebook thingy. I'm kind of a Facebook novice, so I'm not really sure how to do that, but I'm willing to learn about it. But we do have to consider what to do with that data, because it is a self-selected data set, and that could be a problem. So we're going to have to talk about that more once we get some data from there. If you have other thoughts on how to get some more data, for example, some people in the lab did not have another college class, but they do have this class. So from both the Pendleton and Hermiston class, we'll do a random selection of 12 people each, and we'll collect that data. I'll probably be sending that out on email to a randomly selected group. Please respond soon. Other thing is, I don't go to movies very often, but I do occasionally watch a movie from the internet. I use Netflix and Amazon. Somebody else mentioned Hulu. So we decided to ask two different questions. The other question being, how many movies have you seen online in the past 30 days? By online, we mean something like Hulu, Netflix, or Amazon. There's others. And movie, we mean a feature-length film, not an episode of a show that occurs periodically. As far as generating a randomly selected list, an instructor is not going to give you their roster to go pick through systematically. But what you will have is a group of students in front of you that are seated together. And so I created this system random systematic sampling method here, where you enter your class size here, like maybe there are 22 students in the class, and you want to grab every 5th student. And so what it does is it starts in a random spot, and then it jumps through the data every 5. And it does so in a way that, so for example, if you add 5 to 19, you're going to get 24. 24 is unfortunately not a person in the class. There's only 22 people. So what I have it here doing is giving the remainder of dividing by 22. So if you take 24, you divide by 22, you have 2 left over. That means we're recounting at the beginning, and we're going to end up with a second person in the class. I do need to fix it to get zeros out of there. I'll do that before you start using it. But this is here as a quick way to get a systematic random list of numbers. So then you'd want to grab, like you would look at the seating arrangement, and you'd want to grab the 19th person, the 2nd person, the 7th person, the 12th person, the 17th person, and so on, to ask them those questions and write down the data. If you have any questions, give me a call. That's it for now. So have a good day, do good math. I'll see you soon.